Imagine you're with your friend. How you see your friend? When there is a light. Light comes from the sun and it is a ray that reflects from your friend's body, goes into your eye, and then the retina forms the image. And all this might take some nanoseconds, but it takes some time. So basically, we can say that you are seeing the past. So where is the present? Do it exist? Yes, it exists, but it's too quick that we cannot catch it. And when there is a present, there is a certain past. Quick past, it falls us into an illusion. So we can say the time is an illusion. There is a theory that time is relative but not absolute that the Newton said. Unfortunately, he failed in this race but won in gravity case. But the Einstein said the time is relative, which means it changes with different scenarios. Which scenarios? There are two types of scenarios. When we increase the velocity of an object, super fast velocity, so the time slows. We call it specific relativity. And when there is an object closer to heavier mass or dense gravity, then time slows as well. We call it general relativity. All this variation in time, we call it time dilation. See the Venus. 1 hour on Venus equals to 243 Earth days. Similar for Mercury, the 1 hour on it equals to 59 Earth days. So it means there is a slow rotation with the time dilation. So rotational speed is also another factor, as it decides how fast or slow a planet is rotating about its axis, which eventually delays the sunset or sunrise or vice versa. But in the case of Pluto, where 1 hour on Pluto equals to 6 hours on Earth, there is no time dilation factor. We talk about time, then we talk about the space-time. It is a graph, or we can call it a grid, called metric. The curvature of metric, we call it gravity. And the deep single point of the curvature, we call it singularity, where the science shuts down. The velocity vector affects also the time. We can see this by considering a graph between time and space. If we further break the space graph into xy plane, we can make it like this, where there is a resultant velocity vector, because we know velocity equals to distance upon time. And when there is resultant, there are components also. So we can consider Vx and Vt. Vt will be the velocity component in the y direction, which is the time. Since on increasing the velocity, we say the time slows, so we will increase the velocity along the x direction, which makes the velocity vector tilt along the x direction and reduces the velocity factor along the time, hence making the time slow, and eventually on increasing velocity, time slows.